Okay, solving rational equations both graphically and algebraically. So let's start with the rational equation, like. Okay, so 2 over x minus 3. What are the non-permissive values? What restrictions do we need to keep in mind? Okay. So one thing when we solve rationals is we have to keep the restrictions in mind because we need to check back against them when we solve this. Okay? Because the methods we use in solving, not graphically so much, but algebraic methods of solution may result in introducing what are called extraneous solutions, right? So, method 1, 2 methods for doing it graphically. Method 1, we're going to do y1 is the left-hand side of the equation. And y2 is the right-hand side of the equation. And look for the intersections, right, between the two. So, let's pull up a calculator. I'll use the 83 because I think more of you have 83. Really? Alright, we'll use an 84 because more of you have 84s. 84. Okay, so y equals 2x divided by bracket x minus 3 plus, oops, gonna close the parentheses there, plus x divided by x plus 3. Now, I want to get an idea of what this graph looks like before I graph the other one, right? Okay, so we can see what we're dealing with for y1, right? Now we're going to graph y2, which is 18 divided by bracket x squared minus 9. Okay, so potentially we seem to have intersection here, somewhere up here maybe, and a couple down here. Yes?
One of the PDs isn't
Square root of 9.
Oh, okay, I see.
And that square root of 9 might be what? Yes. Entirely correct. Okay, so let's look for our intersections. So we're going to look up here somewhere, right? Okay, so second calc intersect, and I want to see where we are, right? So 0, 0. We need to be down around negative. Let's see where we're tracing down here, but this will jump. We need to be beyond negative 3. So there we are there. So I'm just going to hit enter 3 times. 2 and negative 3.6. Kind of interesting because it jumped over to here. All right, well, we'll take that as a point of intersection, but still, is it like further up there? Do we need to, well, let's find, maybe, is there one over here maybe? Now that we're here, let's just move down. seems to jump back there. Let's go look in the table then. Well, the error is at 3 and negative 3, right? We know that. Are there any values? Maybe not. These values are approaching 3. These values seem to be approaching 0.
Oh, I did something wrong.
You can do that next year.
Yeah, you're right. Don't do calculus.
Let's see what's happening on the other side here. These values are tending to 3. These values are tending to 0. So is that it? We just have that one intersection point then, maybe? Let's go to decimal. So I always like using that, right? So what do we have? Y equals 2x over x minus 3 plus x over x minus 3. Whoops. Why did it do that with the 2x? Oh, that's not it. So by x minus 3, x plus 3, and 18 divided by x squared minus 9. Okay, so we have the one point of intersection here. Slide down, we can zoom out. There's a maximum point there.
I see the point over there.
So it doesn't appear to be any other intersections, right? Okay, so method number 2. It's a bit of a problem looking for intersections, right? Maybe it's easier to do what? It's easier to look for zeros. So we can rearrange this equation so that it's equal to 0. Then we're simply going to graph this as y1. And if we like, we can graph 0 as y2. And then we just have to look for the zeros, right? Which is easier now because we know where we're looking just along the x-axis. So let's try that. So I'll go back to y equals plus minus x squared, 18 divided by bracket x squared minus 9. And in y2 we'll graph 0. 0. So we expect to see something at 2. Oh wait, there's another one there. Did I graph this wrong? Yes. Alright.
Alpha and then y to get. You have to add the whole thing. So you can make it look like this.
Oh, right.
What intersect what? Yeah. Use alpha and y equals.
Alpha and y equals?
Here. Oh, I see. What is he talking about?
Alpha and y equals. Okay, so hang on. Let's clear this out. Like that? Ah, nice. So 2x over x minus 3 plus, do it again, x over x plus 3 minus 18 x. Okay, so we expect to see 1 and 2, and that looks like about all we're going to see. Okay. Alright, so what's the solution then? X equals 2. Compare that against the non-permissible values, and okay, good. Alright, well, graphics all fine and well, but messy, obviously, right? And I messed up when I graphed it, and on the 83, I would have had no choice but to bracket things. So we want to be able to do this stuff algebraically, right? So to solve algebraically, what did we have? Let's go back. 2x.
No, you don't say.
Okay, so first step is to do what? What's the real first step? So the real first step is to factor all the denominators, right? Then we state the non-permissible values. So as not to confuse anybody. Okay? Okay, so we got 2x over x plus 3 and x. Okay, now we state the non-permissible values, which are x is not equal to plus or minus 3. Then we multiply everything by x plus 3, x minus 3, giving us okay, now we're going to expand it all, move the 18 over, set it to 0, factor and solve, hopefully, which we know it should because, you know, it's got to be like an x minus 2 squared or something, right? So 2x squared minus 6x plus x squared plus 3x minus 18 equals 0. So we get 3x squared minus 3x minus 18 equals 0. So we get x minus 3 and x plus 2. Negative 2. The 3 we have to reject. I thought x was 2 though. Why is it? Did I flip where? Oh. Here. Oh, right, okay.
Oh my god, I was doing it right.
Actually, I wrote it out wrong in the first place. So.
Yes, I was doing it right. So happy. Wait, so this was wrong. We have to factor that out.
Okay, where are we? So 2x squared plus 6x plus x squared minus 3x minus 18 equals 0. 3x squared plus 3x minus 18 equals 0. So we divide out the x, or the 3, sorry. Then we factor. Okay. Now, show the x equals negative 3 and then x it out, reject it, okay? But you need to show it as a solution. Because it is a solution to this, it's just not a solution to the original problem. Okay, so that pretty much shows the answer. It shows that we've rejected this solution and that we have chosen this solution. That's good enough. Questions? Comments? Concerns? Should I copy this down, right? Like, I know my writing's not the greatest, but seriously, you got a t squared out of that somehow?
Yes. Yes, I'm blind.
Oh. Better? First of all, my t's look like this, so as not to be confused with my plus sign.
That looks like a Cartesian plane.
Yeah, I know. For my indication of the coordinate plane. Okay, first step. Okay, so your first step is to factor, right? Because otherwise we're going to end up with a 2x plus 1 and a 4x plus 2, and you'll be multiplying by way more than you need to, creating unnecessary, angst. So x is not equal to negative a half. Okay, what's the lowest common denominator? Times? Times? Okay, everybody good? Right. Kind of shortcutting it, right?
It should be over 2. Yeah, over 2.
Man, you got to figure out your LCD.
Where did that extra clear go?
Good advice. Take your advice. Okay, so. So, I don't know what works. What are we going to try? 2 and 2? Need a 3, so this will give me like minus 6 plus 2. 4x squared minus 6 plus 2 minus 3 works nicely. So, x equals? Which is a non-permissible value. Okay.
It's good money. Good money.
So writing it out as a solution set.
Have rich. I will be right in the eye. Here, that's so much.
Okay. Questions?
Where'd you go to?
So one or the other, right? X equals 3/2 or the set consisting of 3/2. One more for good luck.
No, I never helped. Oh, that's nice.
Step number 1. Oh, you know what? I'm not recording this, am I? Oh, well. Oh, yeah. Yeah, it's just down there. Okay. But the microphone's not plugged in, so it's just using whatever's on the computer. Well, then, if there's no sound, there's no sound. Okay, first step. Let's talk louder so that it picks up. Okay, so. So there's nothing to factor, so we're not going to do that. We are then going to just state the non-permissible values, right? So -1 and 2. We're going to multiply through by, giving me 3 times, plus 5 times, equals 2x times. And all you got to do is solve that, right? Expand it out.
Oh crap.
Yeah, look for mistakes. Maybe I'll make one on purpose.
Oh my god. I don't want to do it. I don't know what this thing is. Oh, this is the Romeo and Juliet. I have no life.
Okay, are we good to this point, or before I go on? Before we go on. Okay. Yes? People agree? 1 or 2? People whose opinions I respect agree? Yes? No? Well, in this case I will, actually.
Will respect.
3, 16, and 4. So I get like a 3 and a 1, and then a 16 and a 1 and a 4 up down. I don't think it's going to factor. Doesn't factor. Well, it means we don't have to worry about the non-permissible values then, because they're integers and if it factored, right? So what's x equal to? X is equal to? Nice.
It's so good, what the hell? Dude, this is so good.
Are there any solutions? Yeah, how do we know? Because that's going to be positive. Discriminant will be positive. Lincoln's speech, 4 squared, and so many years ago, forefathers brought. Oh, it's 4 score. Never mind. The Gettysburg Address. 4 squared and.
No, 4 score.
4 score. What's the score? 80 years, right?
20 years.
Score.
Score is 80?
No, 20 is a score.
Oh, okay. I don't know.
It's an old system. It's like rods and chains and how many what? Like 20,000 leagues under the sea? I don't know. Plus what? 192?
I just got 2. 208, yeah. 208.
All right, so 208 is what?
16 times 13, so 4.
Okay, good, right? Because non-permissible values were integers. There's